Hello everyone, in this tutorial we'll be simulating a 2D cylinder in freestream that's spinning to produce the Magnus effect. So here are the case files for the tutorial. This is the OpenFOAM case, the mesh in Gmsh, and some results that I'll show you at the end of the video. So let's go over the mesh first. Here we have the domain boundary, which is defined by the freestream boundary condition in OpenFOAM. And here is the cylinder wall, which is defined by the rotating wall velocity boundary condition, otherwise a wall, but on the velocity it's a rotating wall velocity. So I'll show that later. You can see that this is a hybrid mesh, unstructured up to the domain, and structured near the mesh, near the surface. So yeah, this is done very straightforwardly in Gmsh, and yeah, done to resolve the boundary layer. This may not be actually sufficient, but I just demonstrate that you can do a boundary layer, like an inflation layer mesh type thing. So let's produce the mesh. The commands are in the README. And of course you can find all the code on the GitHub page. Link is in the description. So we've generated the mesh, and we will convert the mesh. And now it is in OpenFOAM. Now we need to modify the boundary file. So the front and back patches are empty. The cylinder is just a wall, and we'll leave the domain boundary as a patch, since it is the freestream type, which doesn't need a specific specification in the boundary file. Remember, this can be automated by any script, such as Python. You don't have to do it manually. Okay, and now that's done, we're ready to run, but first we'll go into the 0U folder to look at the velocity boundary condition and the freestream. So this is the freestream. I just set it to 10 meters per second here, and this is the cylinder surface, and so we use the boundary condition rotating wall velocity. We'll set the origin at 0, 0, 0, and we'll set the axis to the z-axis pointing out of the screen. And this is the rotational velocity in radians per second. So I've set it to -200 to spin clockwise. With that, it is ready to run. So all you need to do is go in case and type in pimpleFoam. But you'll notice I've already run it to completion here. So, because it does take a little while, because I set the time step pretty low. But all you need to do is press pimpleFoam and it'll run. So let's just look at the results. So here we have the results. Okay. So you can see there's a transient simulation, we have some evolution, and now the sort of steady flow field for the Courant number of 2, which you can change in the control dictionary. So you can see it's spinning in the clockwise direction. We have a high velocity up top and a lower velocity on the bottom, and here you can see some separation. This may or may not be accurate due to our mesh. You have to perform a mesh convergence study, but this captures qualitatively what we'd expect from a Magnus effect in viscous flow. So that's all there is to it. Thanks for watching, and happy foaming.